Hello everyone and welcome to the intro lesson to the BE Maker lessons. This is called the Potato Light, and we will be actually creating a light using several, more than likely, potatoes. So in this lesson though, I want to teach you about voltage, current, and resistance. So we can get started with a thing called Ohm's Law. And again, I'm not going to go into detail yet on Ohm's Law. I just want to kind of give you the basic rundown of it. So voltage equals current times resistance. So with this formula, we can figure out our voltage, we can figure out our current, and we can figure out our resistance. And just by doing a little bit of algebra, so if we want to, for instance, find our I, we can find our I by using V over R, which is our voltage over our resistance equals our current. And the same thing goes for if we wanted to go, say, voltage equals I times R. If we wanted to instead divide I by both sides, we would find our R. So so you understand that these all correlate with one another. Our voltage correlates with our current correlates with our resistance, and they all work with one another inside the exact same system. So I just wanted to get that basic rundown of Ohm's law on here. Another thing, I want to introduce you to a few components. The first is a battery, and you've probably seen batteries like this one. This is just a standard alkaline 1.5 volt battery, and used in many electronics, used to power all kinds of toys and music machines and whatnot, like a radio. So that's a example of a battery. Now we're going to be using a potato as our battery, and again, we're probably going to be using several of them. And we are also going to be using a thing called an LED. Now this has, so LED stands for light emitting diode, and it is exactly that, is a diode that emits light. Now the cool thing about this is you won't be able to hurt this LED with the potatoes. You can hook it in backwards and it will just be a reverse bias diode, which you won't be able to saturate, and you won't be able to actually harm this thing because you don't have enough current within those within the actual potatoes. So the diode, the LED, has two leads. One's an anode, which is your longer, and it's your positive, and then the other one's shorter, and it's called the cathode, and it's your negative. So the negative actually, in this example, in this lesson, will actually be connected to your dime or your nickel, and your positive lead will be hooked up to your penny or whatever other copper, maybe even a copper nail if you have that around, or whatever currency you have lying around that could be copper. So next up, we'll take a look at the paperclip chain. So now you're going to need about 30 or so of these non-insulated paper clips. Very important to be non-insulated, otherwise you won't have a connection between the 2 points here. So you can actually check that out if you have a hardware store around the corner or something like that. You can actually make sure your paper clips are making good connection just by doing a quick continuity test. So if I do this and this, and so I'm shorted, which is good because that means I'm connected from this point here to this point here. So again, you can't do too much sag because then it just doesn't make its connection. So just make sure when you put it on the battery, or the potato, it's pretty taut. But again, you should be okay with just a little slack in there. Last but not least, you have your potato, and you're going to need several of these probably. I know I used 3 or 4 and it finally lit up dimly. So that's, unfortunately, they just don't supply that much power, which we'll go over power a little bit later in this lesson. Now you can hook these up in parallel or in series. I'm going to show you how to hook them up in series. And if you want to try parallel, I can make another video later on where I show you guys how to hook these up in parallel. So parallel, just so you know, parallel means you'll have more current, and in series means you're going to have double the voltage, or depending on potatoes, they're not really double because they're not really consistent, but you'll have voltage plus voltage instead of current plus current. So now go ahead and talk about also the fact that you will need a penny, or several pennies that is, and you'll need several dimes or nickels. Now, the reason you'll need the penny is because that's your positive terminal of your battery, which again you'll need to hook your paperclip chain to eventually. And then also your dime, you're going to need it because it's your negative, which that's actually your the phosphorus from phosphoric acid within the potato is actually going to flow from your negative to positive terminals. So you could also again use nickel if you need to. Okay, so that should do it from a hardware standpoint, but I also want to teach you a little analogy about voltage. So voltage you can voltage, current, and resistance can be put into a water analogy. So the voltage could be the pressure of the system, of the water system, and the current is the water flow, and then resistance could be whatever load you're putting on that water. For instance, if that water's turning a wheel or something like that, that would be considered your load. Just like in electricity, when you put a motor on a battery, well, that motor is the load of that battery, and then the battery's supplying the voltage and current, which is the power. And that's actually exactly what the power equation is P equals IV, which is power equals current times voltage. So now that we have that understanding, we can actually move on to doing the exercise. So stick around. Alright guys, so first we're going to need to gather some of our hardware here. So the first thing you're going to need is a few potatoes. I have a couple here, but you probably will need a few to several. Just like I said, just the power is just not enough. They don't supply enough. You'll need several paper clips that are uninsulated, and then you'll need to put them in chain form, and I'll show you how to do that in a second here. Then you're going to need a couple of dimes. Anything nickel will more than likely work, so I use dimes. They're practically made of nickel. If you don't have a dime, you can probably use especially if you're in another country, you can probably use something from your own country as far as currency is concerned, or you can use a galvanized steel nail and a copper nail. So those are suggestions. Also, some pennies. The dimes will be our negative, the positive will be the pennies. And then, of course, I'm going to need your LED. That's just a standard LED, nothing special, just a red LED. So as far as that's concerned, those are the components. Alright, so now let's go ahead and create our paperclip chains. Now I'm just going to show you how to create one. You should be able to create the other ones pretty simply. So you're going to take your pin here, you're just going to fit this through. There's one. See, that's 2 links now. You're going to do the same for the other links. Just like this. I use 6. You can use more or less depending on your application. This works pretty well, I think. Just like that. So that's 1. Again, you can easily check it using a DMM if you need to. But as long as it's not insulated, you should have a nice short there. That's good. So I made several of them because, again, we're going to be using several potatoes in order to power the LED. So there's the several that I had made. Now, to make the potatoes, we simply take one of the pennies, stick it in one of the holes here that I pre-made, and if it goes too far in, you can grab a pair of dikes or a pair of pliers and grab it out just like that. You want to make sure it has enough area to grab onto. Stick the dime in there as well, and then you can even move the penny if you want to. So that's one. Now for the next one, need another penny, another dime. Stick it in there again. Same thing for the penny. Just like that. Again, you just want to leave enough room. The dime is your negative and your positive is your penny. So if you want, you can shorten these if you need to, if they're too long, because I don't even want to have to hook up chains to the penny and dime if I don't have to, because you want to make sure these are close enough to where you might be able to just connect right to the from the LED to the penny and dime, because those are, again, your positive and negative. So now I got 3 here. You could technically do even less or more if you needed to. And again, if you need to, you can always move your penny around, move your dime around to get them closer to one another. Because this is where actually you will be connecting your LED. So this is just 2 of them. Remember, your long lead of your LED is the anode and the negative is your cathode. So what you're going to do here, you're just going to connect them just like this. Now, you probably can't see, it's extraordinarily dim and I can barely see it, but it's, again, you might need more potatoes in series or in parallel to get all that power. But just remember that you're hooking your anode of your LED to the penny and your cathode to the dime. That's your positive for your anode, your negative for your nickel, so in your cathode. So again, you can disassemble it and add more, and in order to add more, actually, let's just show it real quick. If you wanted to add, say you wanted to add another battery to this, you could quite simply just by adding another paperclip chain to your negative, and then the other, you'd have to make another potato up and you'd put it to your penny, and thus have 3 batteries instead of 2. And I'll show you that schematic in a second here. And again, you would connect your anode of your LED to the positive, and your cathode of your LED, which is the shorter lead, to the nickel. So now let's go ahead and take a look at the schematic we just really created, the circuit that we just created. So really what we created there was 2 batteries. So this is the symbol for a battery. So you've got your negative, your positive, your negative, your positive. And then you had your LED here. And then you connect it here. So this is essentially what you had here. So whatever your voltage on your batteries were, which again the potatoes don't really supply much power, so they're probably very low voltage and very low current. You need to source 20 milliamps to your LED to get it to be pretty bright, and quite bright actually, because it's a red one. And because we have them in series, if they were say 150 millivolts a piece, let's just give them that, we would actually be adding 150 millivolts, 150 millivolts, and we'd get the 300 millivolts is what we'd end up with by this. Now, current-wise, depending on what this is, which again, this is red, it's going to at least be hopefully supplied with a nice 20 milliamps, which will give you a nice bright LED. If you accidentally hooked up the LED like this, you don't need to worry because you did not saturate this. So this acts as a wall pretty much right there. This right here is a wall, because you don't have enough current to saturate that and actually bypass that diode. If you did, you could possibly damage it, but you didn't. So if you did hook it in backwards, don't worry, just reverse it, and if you need to, add more potatoes to get that power. So, and again, we'll go over power a little bit more in detail in the next few lessons, just to get an overview of what we can do with it, as well as Ohm's law as well. We will go over it. So again, if you wanted to also if you wanted to add another battery to this, you could. Again, these are potatoes, so these are your potatoes. Now you can add another potato, 150 millivolts. That's assuming they're the same, by the way. They're probably not very standard. That would be your circuit at three batteries. So you'd end up with about 450, because you'd add all these up. You'd end up with 450 millivolts instead of the 300 millivolts you had before, but you'd end up with the same exact amount of current. So I'd like to thank you guys for listening, and I hope you come to the next lesson, which I will be going over the Arduino IDE, also controlling the Arduino with a basic paperclip switch. Finally, reading voltage from a potato, which again we'll actually be using a potato to read an analog input, which we'll also be going over in that lesson. So thank you very much, and have a good day.